Welcome to this lesson on using rates. Today we're going to talk about how to, again, turn a ratio into a rate, and then how to use those rates to help us solve real-life problems. So here we go. We're starting with a little bit of review. So we have the ratio of miles to the number of hours. So miles to hours is 434 to 7. And we want to write that as a rate. So remember, we have to have that per line in there, and we have 434 miles per 7 hours. So remember, when we write it as a rate, it's always in fraction form. Okay, and then we're going to take the ratio of the number of laps to the number of minutes, and we are going to write that, so it's 5 to 4. And we're going to write that as a rate. So we have 5 laps per 4 minutes. Again, this is a rate and not a unit rate because we're not comparing it to one unit of something. We're comparing it to multiple units, so multiple minutes and multiple hours. All right, so it's simple when you're taking a ratio and turning it into a rate. You just need to make sure you put your pieces in the correct place. And as you're starting off, it's a good idea to write down, okay, this is the order of my labels, match up your numbers with your labels, and then put them into your rate, with the first one being listed on top and the second one being listed on bottom. Okay, so now what we're going to do is we're going to fill out the model below using the ratio from example 1. So we are going to use the laps. So the laps of 5 to the minutes of 4. And we remember the ratio was 5 to 4. This here. Okay, and then we have the unit rate. So now if 5 to 4, so we have to do a little work, is my rate, I have to divide both of these by 4. And I am going to get 1 on the bottom. And I know that I will get 1 in 25/100 laps on top. So my unit rate is 1 in 25/100 laps per 1 minute. Right. Now as a rate, I just write this as 5/4 laps per minute. Now notice I read this as a fraction and said 5/4 laps per minute. So I read this almost like it was a value. Okay, so it isn't a value in this case because it's a rate, because it's comparing two different things, but think of it in terms of a value and in terms of how we write our sentences. So I want you to keep this in mind as we move on from here. Right, so what I'd like you to do is I'd like you to try this one on your own. So you have a rate of 6 feet per second. Now we can go back and we can turn this one into a rate, as it's already a unit rate. We can turn it into a rate. We can also say that this is 1 in 25/100 laps per minute, but we're going to focus on using it as 5/4 right now. So here's your rate, 6 feet per second, and I want you to try and write your unit rate and then your ratio, and when you come back, we'll check your answers. All right, so here your unit rate would have been 6 feet per 1 second because that's actually what they gave you. And then here your ratio would have been 6 to 1. Right, so sometimes your rate that they give you is actually your unit rate as well. Okay, so as long as you're able to convert between these, you're moving along just fine. Make sure that you're practicing those and able to turn it from a ratio to a rate to a unit rate. I would not expect you to go straight from a ratio to a unit rate. I would say be able to go from a ratio to a rate to a unit rate. But you should be able to go from a unit rate directly to a ratio, as well as from a rate directly to a ratio. All right, so let's take a look at this and how we can use this. So Dave can clean pools at a constant rate, so constant rate means that it doesn't change, he doesn't go faster or slower, of 3/5 pools per hour. 3/5 pools per hour. Okay, so again, this sounds like a value, so you can kind of treat it like a value in terms of creating an equation, so keep that in mind when we go to B. However, we want to know what's the ratio. Well, 3/5, and I know it looks like this. Remember that when you see fractions written like this, the first number goes on top and the second number goes on bottom. And then with your labels, the first label always goes with the top number, which is the number listed first, and the second always goes with the bottom number. So the ratio in this case is 3 to 5 because they want the ratio of pools to the number of hours. How many pools can Dave clean in 10 hours? Well, we have a couple of ways that we can do this. We can use equivalent ratios and say that we have 3 to 5, and we want to get to 10 hours, which is x. We know that 5 times 2 gives us 10, so we multiply by 2 and we get 6 pools. Okay. However, I'd like us to get to the point where we can say, okay, well he can clean 3/5 pools per hour. So if we take this and we multiply it, so 3/5 pools per hour, and we have number of hours, and we can multiply it by 10 hours. Oh, and I apologize, I did this backwards because I read that as pools. Oh, no, I did it right. I'm losing my mind here, sorry. So 3/5 pools per hour. And since it's number of hours, so basically if it's the bottom label that you're using, you can multiply it. So multiply it by 10. Okay, and that should give you your number of pools. So here's why that works. So we're taking 3/5 and we're multiplying it by 10. Okay, and then this is hours and this is hours. So it's 10 over 1. Okay, so this is pools. Because remember, when you multiply with fractions, you multiply straight across. So here, your units cancel out. So hours and hours cancel out because of the fact that one is on top and one is on bottom. And you end up with 30 over 5, which we know is equal to 6. Right? So again, if it's the second label, you know that you can multiply it by that number. And if it's not the second label, then you have to actually use division, and we will get into all that kind of stuff later. All right, so here we want to know how long does it take Dave to clean 15 pools. So again, you can use equivalent ratios, but you need to be able to do both. So don't just count on being able to do this. And we have 15. And we want to know how many hours that is. So how long would mean how many hours. I know that if I multiply by 5 and I multiply by 5, I get x is equal to 25. So it'll take him 25 hours to clean 15 pools. Now, looking at this, if you just take 3/5 and multiply it by 25, you get 75 over 5, which gives you 3. So it doesn't work. You have to know where your pieces are and what's going on. So in this case, what you would do, okay, and I just wanted to show you mathematically why that doesn't work. So what you can do is you can say, okay, well, I'm going to take this rate and I'm going to change it. I'm going to say that he cleans 5/3 hours per pool. Okay, so 5/3 hours per pool. Because now pools is listed on bottom, so I can take and flip that and say 5/3 times 15. So we have pools and pools. Okay, Those cancel each other out, so we're left with hours. I get 5, and remember, when you have a whole number, we always put that over 1. 5 times 15, so we do 5 times 5 is 25, carry the 2. 1 times 5 is 5, plus 2 is 7, over 3. 75 divided by 3 is 25, so it'll take him 25 hours to clean 15 pools. Okay. So when you're looking at how do I multiply a rate, really the basic rule is just saying, okay, well, whatever you want. So if I want pools, I need the rate to have that on bottom. So I'm going to type this so it goes a little faster and it's a little neater. To get the answer / label that you want, the rate has to have that label / number on the bottom. Okay. Again, something you might just want to jot down so you have it to remember to make life a little bit easier on you. All right, so here we have example 4 where we're talking about Emmeline, who can type at a constant rate of 1/4 pages per minute. At this point, you are going to try these problems on your own, and you're going to bring them back to class completed so that way we can go over them. As always, I'm just asking you guys to try and do your best, even if you get it completely wrong. At least try it. That's all I'm asking. All right, so please make sure that if you have any questions that you email me or write them down so we can go over them in class.